Hey everyone, we're back, and we were just talking about the Sudarium, and both on the Sudarium and the shroud, some of the blood kind of congealed around what must have been a solid image, and there's an image of a clasp like this one here, attached to a woman's chain, which is visible in the blood, like you can see the little links of the in the where the um, where the Sudarium would have been attached to the shroud. And what's interesting is that this could quite possibly been a woman's bracelet, which would have hastily been used to attach the Sudarium to the shroud at the time of the burial. And it's really fascinating because the imagination, it just comes alive at the thought that it could have been like the bracelet of Mary Magdala or even Jesus's mother Mary, to have the bracelet of Mary, um, kind of on this image is really fascinating, I think. Um, Moving on. So, counter arguments to the carbon dating, right? So we can say, okay, it's not a forgery, but what about the carbon dating? And there's some real science here, things that were discovered since 1988, which was pretty far back here. So they discovered that there was a bioplastic coating on ancient fibers by a bacterium. And they chose, and they also saw that there was plenty enough of this bacterium on the actual shroud that throws off carbon dating. So it's possible that the carbon dating was going to be wrong anyway. Next thing is, when they took the sample for the carbon dating, they took all three samples from the same place and took one sample and cut that into three. That's not how carbon dating is supposed to be. You would want one snip from this side, one snip from that side. So you had a variety. What they did was they actually chose the worst possible sample they could from a corner that had been repaired 5 times. And so what they found was that um, since there were cotton fibers mixed in with the linen, that they must have gotten part of the patch. So they used the vanillin test. This is fairly new. They used vanillin which is a chemical compound found in greater or lesser degrees depending on the age of ancient fibers. And a cloth from 1260 to 1390, which is where they said the carbon dating showed, would contain about 40% of the vanillin, right? But the shroud fibers actually showed to be completely depleted of any vanillin, which means that it would be between 1300 and 3000 years old. Definitely not a medieval forgery. This is science. So you have here an example, I'll show up there, of one clean and one colored. Here are some strands from the shroud. Here is the cotton fibers that have the vanillin in it. You can see it's a darker shade. Where you have the linen fibers that are clear and don't have any vanillin in it. So you can see, the difference, and those are they're pretty significantly different. Also, something really scientifically above even my pay grade is what they use a Fourier transformed infrared spectroscopy test. Say that 5 times. This test identifies chemical bonds in a molecule by producing infrared absorption spectrum. So all the wavelengths of light are measured as to its absorption, and that provides a distinct molecular fingerprint that can be used to identify its components. And as they're declining absorption, this allows for us to be able to date the sample. And so when they did this infrared spectroscopy test, they placed the results of the shroud with a midpoint of about 50 AD. There's about a 95% certainty of that. To be off by about 20 years is right within that range. And so this is science again and again is showing just how little that carbon dating really can be trusted. Another thing, and this is where it gets really fun, is the idea of radiation. The image has visible skeletal qualities like the radiation of an X-ray. So they said, well, that the image would have been formed possibly, uh, actually quite probably, by some kind of radiation. First of all, the neutrons would have formed new carbon 14 in the fibers, which would have thrown off the carbon dating test. But also, I want to kind of tell you a little bit about stroboscopic photography. And an example of that is up there in this corner, where you have the ball, the same ball, the photograph taken many times of the same ball as it bounces. This is what is called stroboscopic photography. This happens through multiple quick bursts of the photography or the light, right? So what we have here is that many scholars, scientists today believe this is how um, the shroud was made. Was that there was some kind of energy. Obviously, at the resurrection, if the image was formed at the transfer of energy from the resurrection, what kind of energy would have been necessary for this dead corpse to transfer to a living body? Quite honestly, we don't know. It would require a significant amount. It would require an intense source of energy without having enough heat, right? Because with energy comes heat. Without having enough heat to literally vaporize the cloth. It would also have to kind of maintain the variable to only penetrate, remember, the microscopic first layers of the cloth, not all the way through. Now, first of all, we can't replicate that today. So now you're putting like all kinds of factors. It has to have this, has to have that, has to have this. So now it's like, okay, well, we can do one of those things, but we can't do all three, in a modern setting. And this is where we're getting. And by the way, this would have had to been so precise to turn it into a photographic negative. And it was a 3D photographic negative to cause this image. So what the suggestion is vacuum ultraviolet radiation. So this would be pulsations of ultraviolet radiation needed to happen with an intensity of 34 trillion watts per pulse. Well, remember that our light bulbs are about 100 watts. So 34 trillion, this would be like being about 1,000 miles away from the sun. And if you were only 1,000 miles away from the sun, you would instantly vaporize. So if the shroud was put under this kind of intensity, what, how did it survive? So the only way for this to have worked would have been the pulsations had to have occurred in such short time periods, right? Such short bursts as not to destroy it. And they've calculated this. The pulses would have had to have occurred at 1/40 billionth of a second each. Now, you can say we can't reproduce these conditions. We can only calculate them, and they're not just from anywhere. Choice of the wavelength and the duration and the power used to test the linear, it wasn't arbitrary. It just so happens that it matches up with the right wavelength, duration, and power that is produced when matter and antimatter collide. So it's very possible, if in theory, Jesus' body um, exuded so much energy in this ultraviolet pulses that it caused Jesus to rise from the dead, right? That was necessary to have the body rise from the dead. It would have also had a unique effect, and we'll talk about that in a minute.